Welcome to Chrome Extensions, the new Rootkit. My name is Eric Poynton. I'm the lead network threat hunter here at Awake Security. Quickly before we begin, I do want to recognize Cybersecurity Summit in Denver. Thank you very much for hosting this wonderful conference. And thank you to everyone out there that is listening. I do appreciate your time and attention. So let's jump right in. So quick, agenda, quick who am I, and then we'll jump right into, what are browser extensions, where can they be downloaded from, how popular are they, we'll build a threat model around them, and then we'll also talk about mitigation. So first, a quick background on myself and why I'm up here today. I approached this topic as a threat hunter and incident responder. I first started my career in InfoSec as a security consultant, and I was mainly focused on the penetration testing of systems and web applications. And that really evolved out of my position as a web developer and search engine optimizer while I was still at the University of Pittsburgh getting my undergrad degree in economics. Since then, I've gone on to become an engineer, I was an analyst, and I currently sit on EC Council's SOC advisory board as a board member there. And for the last year and a half or so, I've been at Awake Security, where I lead the network threat hunting team. And so before we begin, here's some headlines covering a threat report on browser extensions that Awake's threat research team recently published. So you don't just have to take my word for it about the extensions, browser extensions, and the fact that they are something to be concerned about from a security and privacy point of view. You can listen to Reuters, Newsweek, or Forbes, and the rest of them, New York Times. So let's jump into what we found. So we actually found a single registrar really tying together several different threat cases. And so what we have is a registrar with a little over 15,000 domains that were tied directly to C2, malcode, or exploitative landing pages. So well over 100 Chrome extensions were uncovered in this investigation that lasted several months. So some of these extensions can take screenshots. They'll read your clipboard, so when you copy and paste items. They will harvest credential tokens stored in cookies or parameters, grab user keystrokes like passwords. And so about 60% of them were in the Chrome Web Store, but most others did bypass the store for distribution. And this really did enable, especially that bypassing the store really did enable for massive surveillance. It was found in almost every single network that we investigated. And interestingly enough, it was also extremely effective at defense evasion of most security tools out there, right? I mean, this has been going on for a few years before we were kind of able to uncover it. And so almost all 15,000 domains were misclassified by your classification, sandboxing, scanning, reputation technologies. So all the tools that your typical analyst would utilize to say, to try to judge if a domain was good or bad, all of them kind of failed here, in essence. And so to read more about that, we published, like I said, about a 30-some page report on this with much more details that are covered in this slide. This presentation is really focusing on the Chrome and browser extension aspect of that report. So what are browser extensions? Right, we've heard that there's something to be concerned about from a data, privacy, and security point of view, but what are they? Right, and so they are simply just small software programs that really customize the browser experience. And they enable users to tailor Chrome functionality and behavior to individual needs or preferences. So really just making the browsing experience much more customizable to yourself. And they're built on traditional web technologies such as HTML, JavaScript, and CSS. So the barrier to entry to create these is very, very low. So where do they come from? Or if they're easily creatable, where do they come from? The Chrome Web Store is, as we can see on the right, that is the official store that allows users to download and add extensions to their browsers. However, many of these malicious extensions that we'll see in this presentation may or may not be available in the Chrome Web Store. As we mentioned earlier, about 60% of the ones cited in the report were in fact on the Chrome Store, but the others were not, and they were typically downloaded via phishing, malvertising, or also just bundled with other questionable programs. And so down below you can see here install source not from the web store. So pretty telltale sign within that packet that it was not from the web store. But we'll see other ways of how we can catch them as well. So how popular are they? And so last scan, there was well over 200,000 Chrome extensions on the Chrome Web Store, and many, many more are distributed unofficially, whether it's GitHub or, like I said, bundled with other programs or things like that. But very interestingly about this is, while there's hundreds of thousands of them out there, only a very small portion of them are actually used. And so when we think about it, only 13 Chrome extensions have been downloaded more than 10 million times. And about 90% of the extensions on the store have less than 1,000 downloads. 10% of them, or well over 20,000, have 0 downloads, which means there's over 20,000 programs on the Chrome Web Store that nobody has even touched, which kind of begs the question of what are they doing there? So let's build out a Chrome extension kind of threat model here. Let's take a look at the extension permissions, or in other words, the capabilities that they will have on your system. Some commands from an unregistered extension, tracking users' internet searches and activities, monetizing users' data, and then we'll go ahead and hunt for some extensions within the enterprise, and then also take a look at how we can defend the enterprise here. So taking a look at the extension permissions, right? Extensions really need the ability to read and write data within the browser in order to function. Right? Otherwise, they don't have the ability to modify your browsing experience and customize it to the way that you wish, or the way that threat actors wish. And so as more and more businesses access corporate data through the browser, right? When you think about it, you got all of your O365 apps, your email, your Salesforce, Jira, Confluence, and so on and so forth. The browser extensions have access to all of the data in those, on those sites as well. Again, because it is processing all that data each time you visit a page. And so every time it's processing all this data, it's also going to harvest most of it as well. A lot of sensitive user system information, such as IP addresses, geolocation. And the interesting thing about the geolocation is that they're able to get basically as accurate as a cul-de-sac. So not quite tell you exactly which house is yours, but which one of these 3 houses do you live in? So a bit scary there. Your ISP information, any company information, browser and operating system information, internet search queries, browsing history, and more. So there's a lot there, and there's a lot that can be done with that data as well. And so access to the clipboard really does nullify password managers, right? Because password managers, the way they work, if you're unfamiliar, is that you basically have one master password, and then within that, you basically have that allows you to enter a secure vault, and then that vault basically has all of your usernames and passwords in it. And the advantage of using such a technology is you have to remember one very strong password, and then you're able to set the rest of your accounts to very, very strong and complex and lengthy passwords, and utilize your clipboard, copy and paste, to not have to remember them. So it's very convenient, and it does allow for good, safe password keeping, and it is definitely a worthwhile tool for all individuals out there. However, access to the clipboard nullifies this, right? If I can read what you're copying and pasting, I can read all of your passwords. So there's something to think about that as we go forward. Additionally, user data is often monetized without their consent, and so this just kind of hits at the overarching user privacy and ownership of data, and what that looks like in today's age. And so don't just take my word for it. Here's a list of permissions, or like I said, capabilities from a malicious extension included in the report that we kind of found out in the wild. And so if we quickly look, we can see it's got access to all the URLs that we visit. It's got access to the management, the background, all of the storage, all your cookies, your tabs, your requests. And so as you can see, your bookmarks, your histories, your top sites, what you're doing there. And there you go. There's your clipboard read and write, your content settings, your desktop capture. So it can take screenshots of your desktop. It can access all of the things that you downloaded. Again, there's that geolocation, your identity idle. So whether or not the machine is active or not, whether or not the user is on the machine or not. And that can be used for other things, such as staging, different sets of malware. Let's see what else. We got page capture. Again, going back to that desktop capture, we can do page capture as well. We can set up different proxies and effectively route all the traffic through, through a proxy, through a malicious actor. And then the user really has none the wiser to that. Access all of the system information, your system CPU, your display, your memory, your storage, tab capture, and then we can see these last two, HTTP and HTTPS, meaning all of your unencrypted and encrypted website traffic. So here's a quick list, just a quick code snippet of one of the some of the browser-based malware that I found recently. And we can see here quickly, line 3123, it's going to disable background networking. The next line, disable client-side phishing detection, default apps, pop-up blocking, a whole bunch of things here. Ignore certificate errors. It's going to load the extension. We can see it's going to access some, modify some passwords here with the keychain. And it's also going to unsafely treat insecure origin as secure. So it's going to set up a process on this machine and tell the system basically to trust it and it is secure. So taking a look at some of the malicious behaviors that we've got here, I mean, you can see the top left, I've got them, do have some underlined here in about this pinkish color. And so this is directly, directly from the PCAPs. So what we can see is, do track on browser action clicked, parse user data on the background once the page loads, right? Let's add a search redirect. Let's add tab event redirect. Let's delay that, 1,000. And we can, direct and just redirect. And so what we can see here is, as the user is going through, this is modifying and forcing the user to be redirected in different places and also parse all of their data and collect all of their data as they go about it. Down at the bottom here, we can see another snippet where they were attempting to scrape some cookies. And so you can see, fortunately for the user, the end user here, there were no cookies available for the current selection execution context. And so the actors were unsuccessful here, but it still shows that they do have this capability and they are trying to do that. And again, just another screenshot of some PCAP here. We can see the top here. They are persistent. We are going to, this is going to capture all of the search terms as well. And so as you can see, this user is likely just going to Google here as it's loading up the different tabs. But nonetheless, it is watching everything that users do. And furthermore, it's not even just going to watch them, it's also going to make money while they watch these users. So we're going to monetize users' data. And so we can see that here, monetized equals true. And so they will get money through ads, and that is why they will redirect users, because they will get a kickback out of that redirect. And so it is rather interesting because this infrastructure can get rather complex rather quickly, as we saw in the threat report. So tracking the user's geolocation here. So we can see we've got the IP address, your city, country name, United States, your longitude and latitude here. Then that's what I was saying, that's how we can get such a precise location there. And again, everything from your ISP, your organization, your domains. And then at the bottom here, we can see all the allowed data types. And so, you can quickly see .docx, so your Word documents, Excel, PDF, images, and you can quickly just read through that to see that it basically will accept any and all file types out there. So it is looking for anything and everything that it can get on its users. So something to be aware of. And so we touched a lot on the Chrome store itself, but what about extensions outside of the store, right? What do we do here? And so this screenshot is actually a screenshot of the Awake platform, where we've got specific adversarial models to detect this type of behavior. And so what we can quickly see here is that we do see a GET request for a CRX file, .crx, which is the extension file type. And as we can see, that has been ranked by malicious by well over 17 vendors. So next up, we can also hunt for these extensions with HTTP headers, right? So many of them will operate utilizing TLS, but many will also utilize HTTP. And so when they use HTTP, we can utilize the fact that when a Chrome extension is responsible for initiating a connection or plays a part in initiating a connection, what happens is it does interject a header, and that is what we can see here on the right-hand side of the page, where it is, the origin is the Chrome extension. And so if we just look for header values like that, we can easily see that we are able to pop up, really bubble up those extensions within the network and the traffic that is coming from them. And so here's a look at more of the extracted metadata. And so there is that request header value that I just said, request header name. So it is even saying that it is origin from there. And then there's their value, and that is your Chrome extension ID. And that extension ID is how these extensions are, that is basically their name as far as the Chrome Web Store and the world is concerned. So how do we catch unregistered extensions, right? So what we have within Awake is Ava, which is basically kind of our behind-the-scenes automated security analyst that really helps analysts go through and perform a lot of the legwork that many analysts will do. Some of that is, of course, open source intelligence research. And so what we've got here is, right, if we kind of start here, we can see that we've got the extracted metadata, where we can see the origin is a Chrome extension. So Ava will take that header value and it'll see what the world knows about this header value. And what it can see next is that it is missing from the Chrome Web Store. And so as a result of that, we're now going to trigger an adversarial model to let the end user and the analyst know that there is an extension, unregistered Chrome extension, connecting out to a risky domain. And so last but not least, right now, we need to defend the enterprise. Now we've been able to see why these are an issue for us, right? The type of capabilities, the permissions that they have, how pervasive they have been, throughout enterprises, and the kind of data that they're able to do and what they're able to do with that data, namely really monetize it. And if we also take a bigger step back there, all of that data, when you recognize, where somebody shops, what they search on the internet, what they're interested in, what they like, what they don't like, when they use the computer, when they don't use the computer, how often they use the computer, who they email, what do they email about, what do their work projects look like, right? All of this data can be harvested, sold, and even more importantly, it can be used for very, very effective spear phishing campaigns, right? When you know all of that information, you are able to craft probably the most effective phishing email out there. So it's definitely worthwhile to defend the enterprise against these extensions to really mitigate all of the risk that is associated with them. And so we've got really three good ways to do that. So we can manage them extensions by policy. So we can use GPOs there to go ahead and do that for Windows environments. We can also allow or block extensions in the Google Admin Console or Google Browser Cloud Management if your enterprise uses that. And we can also hunt for the extensions activity, especially for the unregistered variety. Right, the entire act of threat hunting is attempting to find those threats before they actually surface and become worthy of incident response teams stepping in. And so that's exactly what I would also recommend as well is keeping an active eye on your environment. Look for these traffic signals, whether for these extensions, because they are certainly a formidable opponent these days. And so Google also offers a very in-depth 25-page long guide for managing extensions in the corporate environment. So definitely worthwhile to give that a check. And so with that, that is all that we have today. Thank you very much for your time and attention today. Again, please head over to awakesecurity.com to check out the threat report that my colleagues and I have published. Very proud of that work, and we encourage you to check out the platform as well to see how we can help you out. Other than that, thank you very much and enjoy the rest of the conference. Take care.